So hello everyone and welcome to this uh, Ask AuxEn Anything weekend session that we conduct. And as you all know, this is an online platform for civil structural engineers to interact with us and ask their queries related to any RCC steel design concept or projects that they are doing or construction site issues that they might be facing. And this is the 38th such session that we are conducting. So let us begin with the queries. As we always do, I'll take the queries first from the Google form and email, and then we will take the live comments. So let me just start, and I'll put the first query that has been asked. So the first query is from engineer Suraj Gupta from Gurgaon. He is a working professional, and what he is asking about the one-way shear check, and it happens in raft foundations. It happens in raft foundations, especially for taller. I mean, especially when your rafts are heavily loaded. For taller buildings, this happens that your raft foundation is pretty thick and columns are close to each other. Columns or walls might be close to each other, and when you go to check for one-way shear, the d distance overlaps from either sides. What I mean to say is, let me just try and show it to you. So for example, I'm showing a cross section. So this is a thick raft, okay, and there are two walls or columns. Let's take walls for the time being. In plan view, the situation is something like this, that I have this raft, and then I have two walls like this in plan view, and they are close to each other. And what is happening is that when you check at d distance, generally we check the one-way shear at d distance. So when you go to check at d distance, that d distance is greater than x. That means the next wall is also in the same distance or at a lesser distance than the d distance, which is the raft thickness. So this happens especially for uh, thicker rafts in structures which are quite heavily loaded, typically in tall buildings or similar kind of structures. So he's saying what to do in such case. So in such case, what practicing engineers do is that because these are quite close to each other, they will check the shears in this zone. So you check for shear in this zone. So let's say you have made a analysis model in STAD or ETABS or in whichever software you have made it. So you check shear in these regions. Now, when you are checking shears in these regions, suppose you got some V value, or for example, you got some stress value. Now, to compare this, to check it with respect to concrete capacity, what you do is, or what practicing engineers often do in such cases, that because this is within the d distance region, to take the tau c capacity, they will take the enhanced shear strength. Okay, they will take the enhanced shear strength of concrete. Is this clear? So when you have to take the enhanced shear strength of concrete, as you all know that the IS code allows you to increase the tau c value that you get from table 19 by this 2 AV upon, what is the formula? 2 AV upon D, I think. Yeah. No, 2D upon AV, I guess. I'll just show you the formula for shear strength enhancement. So you can do that when comparing it with the concrete shear strength, you can enhance it by the enhancement provision that is given. Let me just search that provision in the code. Just hold on. Yeah, this one. I hope you are able to see this. So 2D upon AV, the enhancement of shear strength may be taken into account in design of sections near a support by increasing design shear strength of concrete to 2D upon AB into tau C. So what you will do is that when you are checking in this region the shear, you directly check the shear stresses that you are getting, tau v values you check, or you check for the shear force that you are getting analytically, and that shear force you can just divide it by BD, VU upon BD to get the. And remember, when you are checking the FEM results, this is usually kilonewton per meter. That means this shear force is for 1 meter width. So you take B as 1000, D as whatever your D is. This becomes your tau v. Now this tau v, when you want to check it with respect to concrete capacity, you enhance the concrete capacity by using this approach, where AV will be what? So AV will be, let's say you are over here checking the shear at this location, this section AA. So when you are checking at this section AA, you take this as your AV. Understand? So this becomes your AV. So this will be 2D upon AV into tau C. So you compare your tau V that you have got, VU upon BD, with respect to this 2D upon AV tau C, and ensure that it is less than the concrete capacity. So this is how you can do such a check, especially in these types of situations where your walls or columns are quite close to each other, falling within the D distance zone. Got it? Okay. So this was the query that was asked. Mr. Suraj is asking, how do we choose AV distance? So that's what I said. Suppose in this region, analytically you got in this region, you were getting the highest shear forces, for example. Okay. So if you are checking for the analytical shear in this region, then this becomes your AV. If you are checking your shear, analytical shear from STAT or ETABS analysis in this region, then this becomes your AV. So AV will depend on the choice of the section where you are checking the analytical shear forces. Got it? Or you can do the inverse way. In this zone, you figure out, so for this region, you try and see at what location you are getting the maximum shear force, analytical shear force value. So if this was the zone in which you are getting maximum shear forces, so then this becomes your AV. Okay. So this was his query. Now we go on to next query that has been put over here. Just give me a minute. Mr. Suraj is asking, what is the 30° they mentioned in the code? Where is this 30°? No, so they are saying that generally, experimentally, what they have seen, that shear failures occur in this. They are saying that the shear failure plane, experimentally, they have figured out that this will occur in this 30° region. That's what they're saying. Shear failure at sections of beams and cantilevers without shear failure will normally occur in a plane inclined at 30° to the horizontal. So experimentally they have figured out that general shear planes or shear failures, these cracked regions, they occur at this angle of 30° from the horizontal. So experimentally worked out value. Okay. All right. Yeah, so this was engineer Suraj with his query. Now we move on to next query. So this has been asked by engineer Venkatesh from Chennai, and what he's saying, how to decide the length of slotted holes in plates for temperature loading. So quite often you might have seen that we provide slotted holes in our plates, especially in steel structures. So for example, if this is my, let's say this is my truss, okay, and this is resting on some columns, RCC columns, and suppose you wanted to simulate the pin roller arrangement. So you wanted to have a pin roller arrangement on site. Now, creating actual pins and actual rollers may not be possible. So, what you do generally is that you will create a pin like assembly and a roller like assembly. So, when you want to create a roller like assembly, what you do is you give slotted holes. So, it's not a perfect roller, it's we are trying to make a roller like assembly. So, suppose I were to show you this sectional view, okay, and this is my bottom chord in, sorry, this is my bottom chord in plan. This is the bottom chord in plan, and this is my base plate. Black thing is the base plate, and I was to provide bolts. So now the bolts that I will provide, this basically I will be using two plates. There will be a blue base plate, and then there will be a black plate, and this blue plate is getting connected to RCC pedestal below, let's say. So this blue plate is connected to RCC pedestal, and then the black plate is connected to this bottom cord, and then your black and blue plates are connected through bolting. I'll just repeat what I'm saying. The blue plate is connected to RCC pedestal, okay, and then your black plate is connected to truss bottom. Black plate is connected to truss bottom, and then you have got the black and blue plate connected together. So what you will do is, in the blue plate, let me show you the plan view of blue plate. So blue plate will have, in the blue plate you will have your anchor bolts fastened. So this will have your normal circular holes, and then there will be anchor bolts passing through it. So these are my anchor bolts. Now in the top black plate, what do you do? In the top black plate, what do you do? So these are my bolts. Just try to imagine. And then instead of having a circular hole over here, I'll cut something like an elliptical hole. Okay. Are you able to understand this? So what is the purpose of providing this elliptical hole? The purpose of providing elliptical hole is that this assembly is, so this, understand, this pink bolt that you see is fastened inside the concrete pedestal. So it is fixed inside the concrete pedestal. This pink bolt cannot move. The blue plate which is connected, it also cannot move. What can move? This black plate can move because it has slotted holes. So because this black plate has slotted holes, this can move, and because it can move, this entire system can also move. So this is how you are creating a roller like assembly. I hope this explanation is clear. Roller like assembly. So this is how you simulate the roller behavior if you are not providing actual roller supports. So these are called as slotted holes. So the question is, how do we decide the length of slotted holes? So length of slotted holes usually is decided by the translation that is expected in your structure. The translation that is expected in your structure. Okay, how do you find that? So you may give a pin roller assembly in your analytical model. Let's say in STAD, you give pin roller assembly, you apply loads, especially this type of contraction expansion occurs for dead loads also, live loads also. It may occur for any type of loading. So therefore I'm not specifying temperature loads over here. It may, this translation may occur for any type of loading. Even for dead load and live load, your system may try to move translationally. So for whatever load you are doing the analysis, you find out the translation over here, translation values over here. Okay, so you find the translation values x over here. Now whatever is the translation value, that allowance you need to give in your slotted hole. So suppose this translation came out to be, just take 5 mm, suppose. So if this translation came out to be 5 mm, this slotted hole has to have 5 mm plus some additional, I would say, extra margin for your system to translate. Okay, so 5 mm is as per the analytical value translation, and then some additional value also for some margin. So this is how you generally calculate the length of slotted hole. The second query is how to calculate the length of expansion joint. For expansion joint, you don't calculate the length, you calculate the width of expansion joint. Okay, so for two structures, suppose you had a large structure, long, this is the plan view I am showing. Suppose it was 60 meters. So at 30 meters, if you want to provide an expansion joint, so this becomes your portion 1, this becomes your portion 2. So this is the width of the expansion joint that you have to provide. So again, for these calculations, especially these are important for temperature loads. So in temperature, you can calculate the expansion that is happening. Okay, and then accordingly you can work out this gap that you have to maintain. Also note that this gap you also may have to check for the seismic requirements. So this also has to be checked for seismic gap, and for seismic gap, the code tells us R1 delta 1 plus R2 delta 2. Okay, if your buildings are similar, then only R1 times max of delta 1 delta 2. If these two portions are identical, then it will be R1 times R, sorry, not R times maximum of delta 1 delta 2 seismic translations. So this has to be given as the gap over here. So this width of the expansion joint, sometimes it is more critical with respect to the seismic requirement rather than the temperature requirement. For temperature requirement, you can just apply the temperature load, see how much the translation is, accordingly decide this gap. But most often this will happen that the seismic requirement will be the predominant thing for deciding the width. Okay, so this was his query, Engineer Venkatesh. Now we move on to next query. And next query is also by Engineer Venkatesh. He is from Chennai and he is a working professional. So he is saying, how do we assess the capacity of composite columns and beams in general? So there are codes which will give you detailed formulae for capacity calculations. There is an Indian code also, which I am forgetting the name. So composite column code is there. I am forgetting its name. In the American context, it is the AISC 360 chapter I think. Chapter I, which covers composite columns and composite beams, capacity calculation both. In the Indian scenario, there is an Indian code, 1 4 something, but I am forgetting. So you may refer to those formulae to calculate the capacity of composite columns and beams. Okay. And then in columns, there will be two types: embedded columns, where there is a steel section and reinforcement inside. So this will be one. No, this is I think called as encased. And then there is embedded, where there will be an RCC section with a steel RCC cross section with a steel member embedded. So I think this situation is called as the embedded, and I'm not sure although, and this is called as encased something, although I may be confused with names. IS Mr. Nitesh Kumar is providing the info. IS 11384 for composite columns. Is it for beams also? Let me check. IS 11384. Composite construction. Okay, so I think it's a composite construction code. So I assume it covers both the beams and columns. Good. I'll just write it down. IS 11384 and AISC 360. Eurocodes, I think Eurocode 3, uh, it covers composite sections. So you could refer to these documents. Also, ETABS is able to do the composite design calculations. So you can refer to the ETABS documentation. Also, you go to ETABS, go to help menu, go to its documentation. Over there in composite section design, you will see the codes for which ETABS is able to do the composite design, and it will also show you the process that it follows. So all these references you can go through for composite sections. I'm also trying to learn these things. So once I'm able to learn them, maybe uh, I would be in a position to help you more. Okay, good. Next query is from engineer Ajinkya Dinapurkar. He is from Noida and he is a working professional. And what he is saying, what width we must consider while checking one-way shear in rafts? So generally, when you are using, let's say these are your walls, and then this is a column, okay, and then this is a raft, and you are checking one-way shears. Now, when you are usually checking for the one-way shears in SAFE or in Stat Foundation or whatever software you are using, generally the values are in kilonewton per meter units. Okay, shear values. What does this mean? That this is the shear force per meter width. Now, obviously, these are FEM results. So, although it's saying per meter, but it's the FEM result at a certain point. So, what you can do is, because these are FEM results, you may like to do some averaging. So, averaging you could do over 1 meter width. Averaging you could do over 1 meter width. Okay, and then take the average of, let's say, take 5 6 values in across this width. Okay, and so suppose you are this is local axis 1, this is local axis 2, and you are checking for V13 shear. So you take this 1 meter width, over this across this 1 meter width you take certain values, take the average value and use that average value for checking. That can be one way. Or suppose you were checking shear in this region near the wall. Now here you may argue that this entire wall will help in shear resistance. So you could take the average across this width, the entire length of the wall. It becomes the width for V13 shear check. Okay. So in this case, you may say that I would like to take values across this complete width, which is the length of shear wall, and then I find out the V13 and then compare it with the concrete shear strength. So what width to take, it's not very clear and not very well explained in codes, uh, especially because all these are FEM based results. So for FEM based results, you cannot have a clear cut guideline. So it depends on the judgment of the structural designer. You need to see the behavior, you need to see how the forces are getting concentrated, how the shear stress distribution is, and accordingly take some average width which is representative of the results. Okay. In isolated footings also, now there are two explanations, that in isolated footing check also, when you take the column, you will see majority of shear is concentrated in this region, which is sort of equal to or closer to the this dimension of the column. So although we take this width, but if you see the shear stress concentration, it is more in this region, which is somewhat equal to this dimension of the column, especially when I am checking for the, let's say, V13 shear. So V13 shear will be concentrated in this region. So now some people say that we should take this width, column dimension, when I am checking V13. But if you refer textbooks, they generally take the entire width of the footing. So in the isolated footings also, there is a debate what width to take. But the width you should take, whatever width you take, it should be representative of the behavior that you are getting. Got it? Okay. So this was Engineer Ajinkya. Now we move on to Engineer Arjun Srivastav's question. He is from uh, where he's from? He's from Meerut, and he is asking. He is asking क्या हमें डायनामिक एनालिसिस करने के लिए स्टैटिक को हटाना होता है या साथ में करते हैं. सो व्हाट इज सेइंग, डू वी नीड टू do the when we are doing dynamic analysis, while we are doing dynamic analysis, do we need to remove the static analysis, or can we do them together? So basically what he wants to say is that, let's say you are running response vector analysis, do I need to remove the equivalent static that I have defined? So the answer is no. You need not remove it. You need not remove this. Uh, you keep the equivalent static as it is. You will require the equivalent static for doing the base shear uh, base shear scaling also. So as you all know that we do the base shear scaling by dividing the static base shear by dynamic base shear. Sorry, by dividing the dynamic base shear by static base shear, we calculate the scale factor, and then according to this scale factor, did I write it incorrectly? Yeah, it should be inverse. Generally equivalent static base shear will be higher, so it will be the equivalent static base shear divided by response spectrum base shear. So this we find out, using this we find out the scale factor. Using this scale factor, we multiply the scale factor to the response spectrum load case. Okay, and then once the scaling is done, then you can use the response spectrum load case for making load combinations for your further analysis design. So no need to remove equivalent static, keep it as it is. While making the load combinations, use the response spectrum load case. You don't need to include the equivalent static load cases in the load combinations. Okay, but no need to remove them. So you first define equivalent static, then you also define the response spectrum, do the Bayesian scaling, and then while making load combinations, include only the uh, response spectrum load cases in the combination. No need to include the equivalent static. Good. So this was Engineer Arjun Srivastav. Next question we have is from Engineer Ramarjun. He's from Bahrain and he's a working professional, and he has shared some images. So what he's saying, kindly confirm if the approach shown is correct. The contractor proposes to construct the RCC walls on the already cast 200 base slab without grouting and without dewatering. If this is acceptable, please share a step-by-step procedure, method statement, including slab wall joint preparation, dowel anchor details, water stop, hydrophilic strip requirements, concreting sequence and curing, QA/QC checks, tank size is this. But then he has shared some images also, so I'm not sure whether this tank has already been constructed or yet to be constructed. So he has provided some images, which I will just show it on the group also. So here it seems the tank has already been constructed. So I'm not sure what is the, or this is a sample from some other structure. So these are the images he has shared. Let's read the question again. Kindly confirm if the approach shown is correct. Now, where is the approach shown? The contractor proposes to construct the RCC walls on the already cast 200 base slab without grouting and without dewatering. How dewatering and grouting are connected, this I did not understand. Without grouting, I got it, but what is the meaning of without dewatering? This is not clear to me. If this is acceptable, please share a step-by-step procedure method. Slab wall joint preparation, dowel anchor details, water stop, concreting sequence. So why do you think these things should be different for this type of a tank and a tank where you are going to do monolithic casting? So even if your wall has already been cast, sorry, your slab has already been cast and you are doing rebar. So I guess rebarring has already been done. There is no grouting that has been done. So grouting compound has not been provided. The rebarring has been done like this, but they have not shown concrete grout. So this is one thing. Further, what I can see is that the concrete also needs to be chipped over here. You need to break this concrete, otherwise this joint form that will be formed will be a cold joint, and it will ini- I mean leakages will initiate from here. So you need to have some sort of roughening up of concrete or breaking some portion of concrete over here. That is essential, that I cannot see right now. Then because this is going to be a cold joint, you can try to even have a block inserted over here, something like this. So this was your raft. Okay, this was your raft pre-existing. You try to chip the concrete and try to have a small little cavity made over here, so that when you do the new concreting, your new concreting then fits in, and there is this type of a joint that is created. Although this is not very ideal shape of the joint. Why it's not ideal? Because the ideal shape would have been like this, where I could have made a protrusion over here in the raft, and then when I do the wall casting, this would have been a better joint than this joint. But then now I don't see possibility of creating a joint like this. So therefore the next best thing is to create a joint like this, maybe. So roughening up of old concrete, maybe if you are able to make a depression in the raft like this, it will be good, because this is the potential weak zone that has been formed. Okay, these two things you can do. And what else he wants to ask? Dowel anchor details. Now, where do you want to provide dowel bars? I'm not sure. Water stop requirements. So, as I told you, uh, water stop, water stopper, because the existing thing does not have any water stopper. If you are able to drill, I don't see the space available to have a drill like this. If you are able to drill, a water stopper here would also be ideal. But the next best thing would be to create a excavation, small little depression in the raft over here by taking out concrete from here and then doing the casting. This you could do. I don't see water stopper will be you will be able to provide water stopper over here. So instead you may try to have this type of a protrusion. If you are able to make this protrusion even better, if you are able to make this protrusion, that is even better. Okay, if not, maybe you try to make this type of depression. So these two things I would suggest. And concreting sequence curing, that will be as per your normal sequence and curing methods. Nothing needs to be changed. QA/QC checks will be normal QA/QC checks that you adopt for general structures. Nothing needs to be changed. You could additionally you could provide nipples over here. So nipple means steel, small pipes, steel pipes that are inserted in this wall before concreting. At various locations you can have nipples, so that uh, After concreting, if there is any issue of water leakage, those nipple locations can be used for grouting later on to take care of the water seepages. Okay, so I think these things can be managed. Mr. Nitesh Kumar is asking edge fillet can be good idea or not. So you are asking about the haunches. Haunches over here again, because the raft has been already cast, again creating a haunch would be a problem. Creating a haunch would be problem because raft is already cast over here. So now if you want to create a haunch, you would again have to do some sufficient chipping over here also, let's say, and then create a haunch over here in cast concrete casting. So yes, haunch is definitely a good idea. For that, then you may have to chip over here some additional concrete that you may have to do. Roughen this surface up, maybe do some rebarring over here also, and then create a haunch. So yes, haunch is a good idea if you are able to have that on site. Second thing I can see over here is that there is no sump over here because there is this raft is already cast. I don't see any sump. So generally, cleaning purpose, maintenance purpose, sumps are a good idea to have. Now, if you're not able to have sump, maybe you can I mean, you can provide a screed over here. Screed means a concrete cement, concrete paste or cement concrete mix, and create a slope in some direction so that the water, if you want to clean the tank or for some maintenance purpose, the water can, due to the slope, water can stagnate or collect at a location, and from there you can do the pumping out uh, for maintenance purposes. So I think these suggestions I can give uh, at a first glance. So this was Engineer Ramarjun, and then we move on to next query from Engineer Yogesh. He is a working professional from Pune, and he is saying, he's asking how to design a slab with 2 point loads on it. So IS code does not cover, IS codes typically does not cover formulae for slabs with point loads. So essentially the code, let's say if you look at the IS code uh, table number 26, if you look at the table number 26, then uh, it covers the slab with uniformly distributed area loads. So for point loads, there are no specific formulae given or no specific procedure given in the IS code at least. So either you use the plate shell theories or you make an analytical model in STAD or ETABS, and then so use shell elements, make a model, and then apply nodal loads, and then try to see the movements, shears, etc., and then design for it. Here you must be careful because it's a point load. You need to also check for the punching effects. So IS code does not provide you any procedure. So this is how you should do it. All right. Okay. Then we have next query is from Engineer Vinayak. He's saying I have sent pic in WhatsApp how to calculate the CG of a conical dome and bottom beam in StatPro software, how to do earthquake analysis, like how to apply the base shear after calculation. No, so regarding the base shear, uh, I had shared this document with Vinayak, Engineer Vinayak, and okay, so let me try to answer the first query, how to calculate the CG. So I guess this document that I have shared with him, it gives the calculation for calculating the CG. Okay, and I think from this geometry, I mean using the basics of geometry principle CG calculations. So for this, maybe you calculate the CG1. For this, you calculate the CG2. For these walls, the CG will be here. For this, the CG will be here. So you do whatever is the, let's say, the cross sectional areas you take. Okay, A2. Let's say this is A1. This is also the A1. So you do that A1 into Y1. You assume this as your base. So from here, you try and start calculating like this. Okay, so simple formulae or simple concepts that you use for CG calculations, maybe you could do it like this: A4 Y4 divided by A1 plus A2 weighted average of CGs, A4, and this will give you the YCG. I think this is what has been done over here. If there are any calculation mistakes, I am unable to answer because I have not made these document myself. So basic concepts you may use to make the CG calculation. In StatPro software, how to do that? So in StatPro software, what my suggestion would be to not model this tank. Okay, no need to model this tank. You can just let's say do the staging. This is my suggestion. You can just do the staging thing, just model the staging. I'm showing you in elevation. These are my columns, let's say. And then there was a, sorry, and then there was this in shape tank. And instead, once you calculate the shear force, what you do is, so this is my staging. Okay, now in stat model, I guess no need to model this, no need to model this. So you just make the staging, and then making a rigid link or making a very stiff element over here. This height will be the height of CG, distance of CG that you have calculated. So try and apply the shear force at this location. So this shear force will be for this tank portion. So for this tank, whatever is the shear force that you have got, earthquake shear, you apply it over here. Okay, and for staging, the software will automatically apply it at all the points, and then accordingly you will get the base shear and overturning movements. Got it? So whatever earthquake shear you have calculated for this container, my suggestion would be to apply it manually in this tank, sorry, in this STAD model or ETAS model, whatever, by creating a very stiff element over here, and that stiff element should be connected with the staging members, and then apply it at this point the shear force that you have worked out. Okay, so this would be my suggestion to you. So I guess these were the queries that were asked on the Google form. Uh, there are no queries. Okay, I have this query from Engineer Shubham. He's saying, while calculating the second order, okay, so he is asking a specific query with respect to the stability analysis. This is the query as per our course on steel structures, steel structure design using AISC codes. So he's saying, while calculating the second order drift to first order drift, should we have to take the maximum deflection or deflection for the same load combination? Code says it has to be maximum, but in my opinion, ideally, logically also, it should be for the same load combination. That is my opinion, although the code says it should be the ratio of maximum second order to maximum first order deflection. But I don't think it is a logically appropriate way to do it. My suggestion would be to do this ratio check for the same load combination. Okay, all right. So this was his query, and then now let us take queries from. Okay, Mr. Vinayak is asking, in continuation to this question, tank wall calculation should be done manually. Yeah, so for this inch type of shape, there are already procedures given, manual calculation procedures for moments, for shears, for uh, reinforcement calculations and all. So you could do the tank portion calculations manually if you are not very comfortable in doing it on the software, and do the staging portion separately. Okay, all right. So now let us take up queries from the live comments. Mr. Nitesh Kumar is asking how to calculate camber in RCC beam 900 by 1200 mm supporting 4-floor stub column office building. Beam span is 15 meters. So I don't have very good idea how to calculate this camber. Maybe the you calculate the deflection, and as per the lateral deflection, sorry, as per the gravity deflection, then you calculate the dead load, live load deflections, and then maybe to take the dead load part of the deflection, you can provide camber. But I'm not very sure about the specific camber calculation, so I have limited knowledge on it. But logically, I would say you calculate the deflection of this girder RCC beam, and for the dead load part of it, maybe you could try to manage it by providing camber. This is my opinion, although I don't have very good knowledge about it. Mr. Nitesh is asking, please suggest good code or any other books for RCC cantilever wall retaining 10 meter to 20 meter height backfill. No, so why do you think with the height of fill to be retained, it will the design of cantilever wall will change? Why do you think so? The concepts related to cantilever wall will remain the same, whatever may be the height of backfill. But of course, if you have to retain 10 meters to 20 meters, which is let's say 3 to 6 stories of retaining earth, a simple cantilever wall may not be a good solution. Maybe you will have to go for some additional systems like counterforts, or so he is saying 10-meter retaining. That means 10 to 20 meter retaining means imagine 3 to 6 stories of retaining has to be taken. So a single cantilever wall will not be economic solution. For such systems, I think you create a 3D frame type of a thing, okay, with the wall being over here, and you will have to have a beam column frame system or try to have a counterfort system. Even counterfort system for 20 meters will not work. So my suggestion would be you may have to go for a three-dimensional frame. I'm showing it to you in the plan view. Maybe a complete frame system like this, comprising of beam columns. Okay, and then there will be a retaining slab over here, and then this is retaining the earth fill. So you may have to think of some alternate system. A simple cantilever wall will not work for 10 to 20 meters of height. It will just not be economical solution if you try to provide a cantilever wall for it. So you will have to come up with a different system. My suggestion would be to go for a 3D frame like this, beam column frame with slab on one side, which will do the retaining part. Yeah, backfill is 10 to 20 meters. Counterfort is good for 13 meters. No, no, it's not about good, bad. It is about the structural efficiency that you can get from certain systems. Okay, so counterforts also they will have their own problems. The solution that you're providing also depends on what kind of soil strata you have. If you have weak soils, then even counterfort will not be able to you will not be able to manage by providing counterforts alone, because the overturning moments will be just too high. So all these things also you need to take into consideration. Okay. Then Mr. Suraj is asking, do we have any concentrated document having design of steel embedded RCC beam that we mostly require in link beams connecting shear walls. No, I am not aware of such document at the time being. As I told you, maybe you can refer to the ETABS documentation, or you refer to this IS 11384 code that was uh, told earlier, or you may refer to the AISC 360 chapter I. Over there, you could get the information about uh, the embedded beams. Mr. Vinayak is asking in continuation to his question on the water tanks. He is asking what he is asking. Can we do two models for the tank wall design and earthquake analysis? Yeah, you could do two models maybe. In one, just make the tank portion, do the manual or do the calculations for it, and then in one you could do the staging plus the tank, not the tank, just make it for staging and transfer the forces that you're getting from the tank to the staging part. So you could do something like this. Mr. Akash Wankhede is asking check for deflection beam and slab. Now, what is the query over here? I did not understand. What is the question that is to be asked? Check for deflection, slab, and beam. I'm not sure about the query. Uh, okay. Mr. Akash, just try to provide more details about your query. Check for deflection, beam, and slab. So we have discussed the course that you have already taken. Just refer to those sessions where we have discussed deflection. We have in detail discussed the process to do the deflection checks for beam, slabs. In detail, we have done those things manually on ETABs. So you refer to those sessions where we have done the discussion on deflection checks. Mr. Yogesh Devare is saying IS 1893 2025 has come. Can we have a session on its explanatory? Yeah, so let it come. There is some confusion regarding whether the code officially has launched or not. So let it come. Then we will discuss. Mr. Akash Wankhede is saying any fixed formula for deflection? No. Deflection depends on the type of structure that you have, on the type of loading, on the stiffness, and all those things. So whatever formula you get are specifically for fixed beam or for cantilever beams or for simply supported beams. Such examples we don't get realistically. So how to check for deflections? We have discussed it in the course sessions. Just go through those sessions and perhaps you will understand it in a better way. Okay. Right. So this is done. Mr. Akash is saying session मध्ये confusion आहे मला. Okay, then what is the confusion? Then ask specific confusion what you have. If there's specific query, you just ask, or you can send me a message on WhatsApp asking your specific doubt. Okay, good. Uh, then Mr. Nitesh is asking, is there any code for this type of retaining structure? Grid support? No, I don't think there is any code. You need to understand the basics and basic concepts of design, and then you need to do these things. I don't think there is any code for this type. Okay, so these were the queries for this session. I guess that's all we have. Now we will meet you next time, next week. And in the meantime, if you have any queries, questions, doubts, you may continue to provide those queries, or you may continue to put those queries in our Google form. And all of you know the Google form link. I'll just share it once again. Just hold on. So let me no. So if you want to connect with us on WhatsApp, this is the link. You can click on this link to connect with us on WhatsApp. And if you want to post your queries, this is the link where you can post your queries. So even during the week, you can use this same Google form for providing your queries. And once every week, when we conduct this live session, we will take up the queries that have been provided. Okay, good. So that's all for this session then. Thank you. And we will now meet you next week. Bye bye.